Welcome back. Problem 6-33. So statement is the shaft is supported by smooth thrust bearing at A and smooth journal bearing at B. Draw the shear and moment diagram for the shaft. So you can see this is the shaft and there is a smooth thrust bearing at A and there is a smooth journal bearing at point B. Now at this point we have a load of 900 Newton and at the end we have a counterclockwise movement of 400 Newton into meter. So you have to draw the shear and moment diagram for the shaft. So before starting this problem, we know that you have when you remove this support, so definitely there will be a reaction force. Let this force at point A is RA and the force at point B is represented as RB. So we will find this reaction force by using equation of equilibrium. So what are the equation of equilibriums? So I will write it. So equation of equilibrium is that first equation is sum of all movement about point A is equal to 0 and taking the counterclockwise movement as positive. Now at point A, one movement is due to this 900 into perpendicular distance is 1 and that will be counterclockwise, so it will be negative. The second movement is due to this RB and perpendicular distance is this 2 meter and it will produce counterclockwise movement, so it will be positive. And third movement is external movement, that is 400 Newton into meter, that is counterclockwise, so it will be also positive. So we will write that RB into perpendicular distance is 2. You can check it. This distance is 2 meter. So this is producing counterclockwise, so it will be positive. Minus 900 into perpendicular distance is this one and that is 1 meter. So plus 400 is equal to 0. So from here when you solve this, you will get RB will be equal to 250 250 Newton. Now we will find RA by using another equilibrium condition, and what will be that condition is that sum of all forces along y direction must be equal to 0 and force in upward direction is positive. So we have actually three forces. One is this RA upward plus minus 900 plus this RB which was 250. Their sum must be equal to 0. So I will write RA which is upward minus 900 plus this RB which is 250. Their sum must be equal to 0. So from here you will get RA will be equal to 650 Newton. Now we have these forces, we will move toward drawing shear force and bending moment diagram. So you can see this is the shaft, this AY is AY vertical is equal to RA is equal to 650 Newton and this BY is equal to actually RB, that is upward, and that is 250 Newton. So for drawing shear force diagram, first of all we will draw vertical line from the end of these beams. So the length between these two lines, vertical lines, is the length of the above given beam. So this is the x direction where you will take the length in meter. V is the shear force in newtons. So at point A you can see we have AY which is equal to 650, that is given. So let each division is 300. So it will be 600. It will be equal to 900. So at 650 will be somewhere here. Clear? So let this is 650. This point is 650. This point is 650. Okay. Now from moving from A to this load, we have no force. shear force. So shear force will remain constant till this point. So I will draw it. This will be a horizontal line till this point. Now at this point you have a load of minus 900. This is below. So 600 minus 650. 650 minus 900 will give you minus 250. So shear force will change from 650 down to 250. Clear? So we will draw it. So this point was minus 300. So 350 will be somewhere here. So shear force will change from 650 to minus 250. Now you can see again from moving from 900 to B point, there is no shear force, so it will remain same till this point. So let this will be same till this point. Okay. At point B we have a load of plus 250. So minus 250 plus 250 will bring the shear force to 0. So it will go to 0. And again from moving from B point to till the end, there is no shear force, so it will remain same. So I will write by using another color, so it will remain the same. This is 0. This is minus 250. Okay. We will now move toward bending moment diagram. So for bending moment diagram, you have to draw horizontal line. And again here you will take the moment in Newton into meter. So let each division is equal to 200, or you can say it is equal to 300. So 300, it will be 600, it will be 900. Now the first moment is the area under the shear force curve will be the area, and this area will be equal to 650 multiplied by this length, which is 1 meter. Clear? So it will be 650. So again this area, you can see the shear force is a horizontal line, so bending moment will be the first degree line with upward slope. So this is 650 will be, let's say this is the 650. So bending moment will be like this. Again, now here you can see that this area is will give you the moment. So this area will be equal to minus 250 into this length is 1 meter. So it will be minus 250. So 650 minus 250 will bring it to 400. So we will locate 400 at this end. So 300 is this, so 400 will be this point. As this shear force is a horizontal line with 0 degree and negative, so bending moment will be 1 degree line and the slope will be decreasing. Okay, now we know that there is no shear force over here, so the bending moment will remain same from this point till end. So this was 650 Newton into meter. This point was 400. And this was the x in length in meter. So this is how to draw shear force and bending moment diagram for the given shaft. I hope you have enjoyed the video, and those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest videos. Thank you for watching and supporting me.